Okay, Sienna owns a coffee shop. So a coffee machine was purchased for $12,000. So this is where you're going to start seeing, remember I said you got to put your VO, underline it, and it's depreciated using the unit cost method. So that's, remember when I was been saying we need to be highlighting this so that we know, yep, we're using unit cost, and we will go to those formulas. And it says the rate of depreciation is 5 cents or per cup of coffee. So there's the unit use, per use. And a recurrence model can be set up to show the value. Now, this recurrence model models year to year. So really when it says calculate the number of coffee cups the machine produces per year. So what you think about it, if see this 1440, that's how much money the machine is dropping by. So it's dropping 1,440 per year. So what we want to know is how much money does that, how many coffee cups does that much money make? So we know that one coffee costs the machine 5 cents. So we'll divide by 5 cents, and we end up with 28,800 cups per year. Now, you have to have a think about it and make sure, because then with these questions, particularly in finance, if you have a logic think about it, it will pick up if you've made a mistake. Now, this is a coffee machine at a coffee shop. So 28,000 coffees made makes sense, yeah? There would be a lot in a coffee shop. So the next question says, the recurrence relation above could also represent the value of the coffee machine depreciating at the flat rate, which is true. This is very similar. See that we've got the flat rate. So we know with flat rate, we see that value, the minus D. And in this scenario, that D is the 1440. So when it asks me what is the annual flat rate percentage, what they're asking here is they're asking for little r. Okay, so that's the question. So if you think about it, we have the D value, and if we wrote out the formula for how D is calculated, it's calculated like this. So if you think we have all the other values, we have what D is 1400. We don't know what R is, but we know what VO was because the coffee machine started at $12,000. So as someone mentioned, we can use solve here, and we can pop that in, and we go for R, and we end up with R equals 12% flat rate depreciation. And that sounds roughly right. The coffee machine dropping 12% in value, that would probably roughly be okay. So down here, the next question, it asks us to complete the rule. So remember when I say, anytime they say the rule, what does that mean? That means nth term. So you would go, now this was we're talking about flat rate. So you would go to your formula sheet and look up flat rate nth term. And if you looked at that, the flat rate nth term is, it's VO minus N times D. So if you look here, this one has the times N on it. So that's where we're going to put the D value. But we need, so how much, it said for after cups have been produced. So this is not actually flat rate. This one is actually unit cost. So let's change that. So unit cost. So D is the per use. So for unit cost here, D was 5 cents. So I pop it in, and that I'll put that here. So this is where that D value goes. But if you have a look, the exams have been a little bit tricky, and they've put a plus there. If we have unit costs, what's that formula say? It says minus. So you had to put minus 0.5 in there because unit cost nth term, it's a minus. And this value here would have to be your VO, which we knew was 12,000. That was the original beginning price. Okay, so that was the trap there. So you need to be really careful. So this is why we're doing the exam questions, because they help. I'm going to help show you the traps so that you can see. So then this one, consider the following four recurrence relations representing the value of an asset after n years. How many of these recurrence relations indicate the value of an asset is depreciating? So first of all, depreciating means it's reducing in value, okay? So that means you would definitely have to be taking something away. So anything that's getting added, that would be growth, wouldn't it? So I'm going to eliminate this one. It's definitely not, that one's not a depreciating. Now, what about this second one? That's minusing, so yes. So a reducing in value, so minusing an amount. So we can see it there. Now, what about here? Now, if you times something, so if you want, just put an example. If I had 100 and I times it by 0.875, I would end up with 8750. Has that gone down? Yeah, so that one is reducing. That's also reducing. And now what about this one? For this one here, I've got it multiplies by a number bigger than 1. So I see growth, but then it takes away. So it said the value of an asset is depreciating. So what we might do is we might just test it with like what I just did then. Pick any number and see what happens. So what I'm going to do is pick 100 and then I'm going to times it by 1.125 and minus, so I can put it all in there like that and I end up with, is it negative? Yeah. So it's also depreciating, yes? So how many, did I do that right? Wait a minute. 100 times 1.125 minus 2,500. Yeah. Oh, yeah. No, but it's, oh, yes, true. So that's what Atticus is saying. Yep. We start at 20,000. So yeah, we need to check that. So times 1.125. It was still minus 2,500. It's 0. So this one doesn't grow or decay. So how many had a reducing value? 2. Yeah, so we should have actually used here 20,000 as our example. So we actually only had one that, oh, sorry, not 2. Just one that depreciated. All right. No, what? Oh, 2, yeah. We did say. Oh, we're marrying this one up. So 2. Okay. The next one, Sally's buys a machine for printing brochures. The machine is purchased for 17,000. So there's your VO. She prints 25,000 brochures a year. So that's just like a number uses per year. That's what they've told us there. Okay, the value of the machine is depreciated using the unit cost. So that's per use, you know that. And then it says the machine reaches a scrap value. When they say scrap value, that just means the depreciated value. They don't say depreciated value. They call it scrap. It just means scrap value. So it says that it reaches a value after 5 years. So pretty much after 5 years. Now, the rule for the value in dollars of the machine after N brochures are printed is, so what you want to do is you look at, if you think in 5 years, this machine must have used 5 times, printed 5 times 25 brochures, 25,000, sorry. And so in total, over that 5 years, the machine has printed 125,000 brochures. So if you wanted to know, we want to know, because it just wants per brochure, just per one brochure. So the way you can work out, which is actually, we need to know what the D is. So D equals amount per brochure. Oh, sorry, can't spell. So what I want you to do here, and this is probably a formula that you probably going to have to put somewhere, maybe in your summary sheet as well, because it's going to come in handy. So this is for, so I'm going to do it in a different color. So for unit cost, if you're trying to find D, which is the amount per use, you can find that by working out what a drop in the value of the asset, the machine. I'll say drop in value in asset, because it might not always be a machine. So we'll just say in asset over the number of uses. So that's a way you can work it out. So if you look at it in this example, it was originally 17,000 and it dropped down to 2,000 after 125,000 uses. So that's how I worked that out, and you end up being 12 cents a brochure. So they want the nth term rule. So I'd go to unit nth term for unit cost. So you have to have VO. So I'll get, nth term, it would be VN equals my VO minus N times D. So we want 17,000 minus 12 cents per brochure, which is E. I'm just going to stop